All right, hello, you guys. As you probably know by now, you guys are in this Algebra 2 class. You guys are probably wondering, like, what the heck, who am I listening to, right? So let me first introduce myself. I am Kevin Kim. I go to Diamond Bar High School, and I'm currently a senior. And I'm a part of Educators of Orange County. And personally, for me, my goal is to help you guys learn because Algebra 2 can be a bit hard, but with the help you have, I really hope that you know you do really good in this class, and I really hope you learn. And make sure that if you have any questions, make sure to email us or let us know, and we'll help you. All right, so then let's begin. Okay, so the title for this chapter is tables and graphs of a linear equation. This is 1.1, and the first thing, the really most important thing is what a linear equation is, right? So the linear equation is y equals mx plus b. And when you graph this linear equation, it's going to be a straight line, right? So, okay, let's look at example 2 here. They give you the equation y equals 2x minus 1. Before we start, um, the equation is y equals mx plus b, right? So your b is your y-intercept, and your m is your slope. And if you know what your slope is rise over run. Like, for example, when we look at this 2 over 3 is your m, right? So when we look at the graph, you see how it goes up 1, 2, and then rise over run. So you go to the right because it's positive 3, right? Because there's a 3 on the bottom. So 1, 2, 3, right? And from this equation, you see that the minus 1 is your y-intercept because, like I said, the linear equation y equals mx plus b. Your b is your y-intercept, right? So when you plug in minus 1, and then you do rise over run, when you plot the points, you get a straight line. And instead of like putting the y-intercept and then doing the slope, you can also just put in points to find your other points. Like when you look at this, you see how he first plugged in 0. So he plugged in 0 into 2 over 3 times 0 minus 1, which he got -1. And then when you plug in, he plugged in a different point. He plugged in 3, right? So 2 over 3 times 3 minus 1, which you get 1, right? And when you plug the points, 0, -1, 3, and 1, he saw that it was a straight line. And like I said before, if it's a straight line, then that means that it's linear. Okay, since we just saw it from a equation, now we're going to look at it from a graph. They give you y equals 4 over x plus 3, right? But then they also give you a table. Usually with linear equations, you're always going to have a pattern, which is called a constant difference. Like, for example, this table, you see how for the x-axis, it's always +1, +1, +1, because it only goes up 1, 2, 3, 4. But then for the y-axis, it goes from 3, 1, -1, -3, right? And it's going down -2. So you can find that your slope is it goes up 1, but then it's going to the left 2 because it's negative. Okay, so we're gonna look at 3 different problems, and we're gonna state whether each equation is a linear equation. So you can pause the video to see. You can try it out for yourself. But but when we look at these 3 equations, remember what I said, that y equals mx plus b, right? And out of these 3 equations, there's only 2 that are linear equations. This one is a linear equation, and this one is a linear equation. Because y equals mx plus b, you got your slope right here, you got your x, and then there is no b value, there is no y-intercept, but what that means is that when you graph it, it just starts from 0. Or for this case, it will be going the other way. Um, it applies for this one as well. You have when it's negative x, it's just -1x, which means that when you graph it, it just goes it's gonna go negative, so it's gonna go this way. And like I said, there's no b value, which means that the origin is it just starts from 0. When you look at the last one, this one is not a linear equation because there's a square right here, right? If there's a square, then um, it's a parabola, not a linear equation. So this one would not be a linear equation. Okay, so that is all you need to know for the first section, which was the equation of a linear equation. Like that's the only thing that's the most important. But now for 1.2, we're going to be looking at slopes and intercepts, which is the title of this section. And I mentioned it before. Your slope, in order for if you, like I said, for slope, it's m equals rise over run, right? So rise over run. And if they give you a table and you don't know what your slope is, then you have y2 minus y1 over x2 minus x1. I highlighted right here. That is the equation to use to find the slope. Okay, so let's look at example number 1. So they said find the slope of the line containing the points 0 to 4 and 3 to 1. So you use the slope formula, which is y2 over y2 minus y1 over x2 minus x1. What I personally do is I treat this as my x2 and y2. So I use this first. So I'll put 1 minus, this is your x1 and y1, right? So 1 minus 4 over 3 minus 0, which gets negative 3 over 3, which simplifies to negative 1. Okay, so we have two different equations here, right? So y equals 2x minus 2 and y equals negative 1/2 x plus 3. When we look at y equals mx plus b, when you look at this one, your b is your y-intercept. So you know your y-intercept will be negative 2. But then also for y-intercepts, if you don't like it this way, you can also just do it the math way, which is for a y-intercept, your x is always going to be 0. So when you plug in 0 into the equation, you get negative 2. And the same applies here. You plug in 0 and you get 3. Or you can just look at it, y equals mx plus b, your b is your y-intercept, and you see that your 3 is your y-intercept. Okay, let's look at slope-intercept form, which is the standard linear equation form. There's two. There's point slope and slope form. I mean, there's point slope and slope-intercept form, but today we're only going to be talking about slope-intercept form. So the slope-intercept form is y equals mx plus b, where, like I said, m is your slope and b is your y-intercept. And these are just showing how when m equals 2, like they're just different type of slopes, showing that your m is your slope and your b is your y-intercept. It's just when it crosses the y-axis. When we look at this equation, negative 2x plus y equals negative 3, you're like, whoa, this isn't in slope-intercept form. So you have to isolate the y and put y by itself. So you plus 2x, so you put the 2x on the other side, the left side cancels, and then the right side. So you get y equals 2x minus 3, and you plug in the points, and since your 2 would be your slope and your negative 3 would be your y-intercept, and when you plug it in, you get, it goes up 2 and moves to the right 1. And I'm going to do more examples later on, but right now I'm just going to explain it. The last most important thing is your horizontal and vertical line. So when you have 0, when you look at the slope and you get 0, okay, let's look at this one, right? When you have 0 at the top, you're just gonna get 0. That means your slope is 0. So yeah. But then when there's a 0 at the bottom, when you find the slope, that means it's undefined. And usually a vertical line is a line that has an undefined slope. So when you look at y equals negative 2, you go to negative 2 and you just put a line. But for x, x equals negative 3, you just go to the x and it's vertical rather than it being horizontal. Like I said, I'm going to do more examples, but for now, I'm just letting you know. Okay, so I have two equations here. The first thing we're going to do is put in slope-intercept form, and then we're going to want to identify which is your slope, which is your y-intercept. So you can pause the video here to try to figure it out yourself, but if not, I'm going to continue. You see that your y is not isolated and it's not by itself, so you want it to be in y equals mx plus b, right? So you minus 4x here, and you minus 4x. So when you do this, this cancels out. So you get y, sorry, my y's are kind of ugly, negative 4x minus 4. Okay, now that looks like it's in y equals mx plus b, right? So now pause the video here if you want, like I said. Find what your y-intercept is and what your slope is. But if not, I'm gonna continue. Okay, so y equals mx plus b, right? When you compare the two, negative 4x is your slope, and your negative 4 is your y-intercept. Okay, let's go to the next one. Y plus 2x minus 0. Oh no, your y is not by itself. So you minus 2x, which you get that. And, you know, it looks pretty self-explanatory, right? There's no b value, right? Which means you can either plug in 0 to the x to find your y, which just equals 0, right? Or you can look at it and you see that there's no plus or minus anything on the right side, which means that that there's no y-intercept, meaning that it's at 0. So that's gonna do it here. The first two sections are pretty simple. It's just slope and your vertical line, horizontal lines, and I'm gonna show you one more time. Remember, if it's like this on a graph, you go to -3, and it's gonna be a vertical line. Your x is your vertical line. But if it's like y equals -3, then when you graph it, it's a horizontal line. Other than that, everything I explained is like the most important, and I hope that you guys practice some more. And yeah, if you need any help, let us know, and we'll be there. And that's it for me. And I hope you guys learn something, because that is my goal. And yeah, goodbye.